In this lesson we're going to continue with trigonometry and we're going to learn about the double angle formulae. Now we previously learned about compound angles and that was these, and that was 2 lessons ago. Now we're going to do a bit of work here to prove the double angle formulae. So firstly I'm going to let A equal B or B equal A, we're equating those. And if I start off with the sine of A plus B, that means we've got sine of A plus A, that's sine 2A. Now if we expand that, we get sine A cos A plus cos A sine A. And we can see there that we've got the sum of 2 terms which are the same, so we've got 2 sine A cos A. Now let's do the same for the cosine of A plus B. So we've equated A and B. So that gives us the cosine of A plus A, that's cos of 2A. Expanding gives us cos A minus sine A sine A. And we can see that we've got cos squared of A minus sine squared of A. Now, we can actually rewrite this in 2 other forms as well. So if we go back to this part, and hopefully you remember from National 5 that I have another way of expressing sine squared of A and cos squared of A. So we learned the identity in National 5 that sine squared x plus cos squared x was equal to 1. And if we change the subject of the formula to sine squared of x, we get 1 minus cos squared of x. So we can now replace sine squared of A with 1 minus cos squared of A. And simplifying will give us cos squared of A minus 1 plus cos squared of A, which means we have 2 cos squared A minus 1. Now what if this time we replace cos squared of A? So again from National 5 we know this identity. If we make cos squared of x the subject of the formula, we get 1 minus sine squared of x. So we can replace our cos squared of A with 1 minus sine squared of A, and we're still subtracting our sine squared of A here. So that means we've got 1 minus 2 sine squared of A. So you can see here folks, we've just proven the double angle formula for sine of 2A and cos of 2A. We've got 3 of those expansions there. So to summarise, we know that sine of 2A is equal to 2 sine A cos A, and cos of 2A is equal to cos squared A minus sine squared A, or 2 cos squared A minus 1, or 1 minus 2 sine squared of A. So we need to know how to use those, so let's look at some examples. So example 1, we want to write down the formula for sine of 2x, and part B, write down the formula for sine of 6x. So part A is very straightforward, we already have that up here, so sine of 2x is equal to 2 sine x cos x. So we can write that down. The second one though, we've got sine of 6x, and what would be quite useful is to write this as a multiple of 2. So that is sine of 2 times 3x. We can see here that the 3x is equivalent to our A here, it's equal to our A. And we can see in our expansion we've got 2 sine A cos A, so wherever there's an A, we're going to put 3x. So that gives us 2 sine 3x cos 3x. And that's our final answer. Let's have a look at example 2. We want to simplify cos squared of pi over 6 minus sine squared of pi over 6. Now for this we could work out what cos of pi over 6 is and square it, and then subtract the sine of pi over 6 all squared. However, there's possibly an easier way to have a look at this, so we should notice here that we have this expansion, cos squared A minus sine squared A, and that's equal to cos of 2A, i.e. cos of 2 times pi over 6. 2 times pi over 6 is pi over 3. And cos of pi over 3, and in your head you're thinking that's cos 60. Cos 60 is a half. And that is our final answer there. So just now would be a good time to pause the video and take these examples down in your notes before the screen goes blank, and then complete the assigned exercise for today.